thin film of glass has an index of refraction of 1.53 and creates constructive interference at 575 nanometers. What is the minimum thickness it could have? What is the next greatest thickness it could have? So this is assuming we've got glass, maybe, and then just air. Suppose we could have water under the glass. It has to be fast, slow, fast, okay, for our formulas to work, okay? So we're looking at constructive interference. So 2dn is m plus 1/2. And again, this 1/2 has to do with the fact that there's a 180-degree phase shift off the first reflection. Okay, so we're looking for d, and d is going to be m plus 1/2 times lambda over 2n. Okay, so it's going to be m, some integer, right, plus 1/2. And it's creating it at 575, which is right in the middle of the visible spectrum, nanometers, over twice 1.53. Okay, I think I can do this. I'm smart enough to do this. Okay, so let's see. I'm going to put a 0 in first, okay? So the minimum thickness it could have would be that we put a 0 in for that. I hope that makes sense, because I don't know how to explain it if it doesn't. So 0.5 times 575 divided by 2 divided by 1.53. So 93.95. So if m equals 0, then d is equal to 93.95, or I guess you'd have to say 94.0 nanometers. All right, if m, they want to know what's the next greatest thickness, so let's put in a 1 for that. So now it's 1.5, right? And I get 281.86, so 282 nanometers, right? And if I put a 2 in there just for kicks, right? If I put a 2 in there, it's 469.7, so 470 decimal point. All right. Yeah, all right.